Okay, so the purpose of this video is to demonstrate how to create prefabs and then how to instantiate those prefabs. I've shown this in other videos, but I don't think I've really done it en masse. So you're going to see how to create like entire enemy formations and things like that. So as far as creating a prefab, there's two parts to it. One is you take whatever it is that you're using to begin with as an asset. In this case, it's an image. You drag and drop it into your scene. Now if I was to take that and drag and drop it back down here into the asset, it is now a prefab. And the reason for it is because this is just an image. You can see the settings here. This, however, has the transform and the sprite renderer, so it's actually got additional components to it. So that's all it takes to make a prefab, is just drag and dropping it from the scene into the asset area, because it brings all those components with it. Likewise, if a script was attached, the script would be part of it, as well as rigid bodies and things like that. So let's go ahead and delete that prefab, since that was just for demonstrative purposes, and build what we really want. So we're going to move it even though we don't actually need to, just so the camera image isn't bothering it, isn't in front of it. And let's add Physics 2D, and let's do Polygon Collider. So we're going to zoom in. What a Polygon Collider does is, rather than just, whereas a box collider is a square or a rectangle, and very often if you have like blank space, the rectangle will be around the entire blank space. Whereas with the Polygon Collider, as you can see, it's much more form-fitting. So it gives you much more precise collision detection. Now, we're going to also add, well, let's go ahead and add Physics 2D. We'll add a rigid body, but we're going to put gravity scale at 0 because we don't want it descending necessarily. We can always change that. None of this is etched in stone. You can, even if you turn it to a prefab, you can modify these values. So for the moment, we have the ability to move its position, we have the ability to give it velocity, we have collisions, and we have a sprite image. So for the moment, that's what we're going to give it. We're going to give it a script and stuff, but let's get the prefabs taken care of first, then we can add additional components to those prefabs. So now we're going to drag and drop that into back into the asset area, and as I said, now it is a prefab. It has all those same components. So let's go ahead and delete that from the scene. The next is going to be the missile. We'll drag and drop that into the scene. We'll give that a Polygon Collider. We're going to also give that rigid body 2D, and I think in this case the missile is going to be shot from the bottom up. So let's actually give it a negative gravity scale. Let's give it -2 for now. We'll give it a slight linear drag, kind of just placeholder. We can always change these, as I said. Now I want to point something out. Usually when we talk about velocity, we say a positive number goes up, a negative number goes down, because you're increasing the y or you're decreasing the y. Well, since this explicitly is referring to gravity, it's just the opposite. Positive gravity pulls it down, negative gravity makes it go up. So you kind of just have to keep those two seemingly contradictory methods separate, and know which one you're doing, because you can affect gravity scale via a script, but you can also change the velocity via script. Okay, so that we're also going to drag and drop and bring it back down here. And we're going to delete the missile. Now this is going to look a little different, because normally you see me assembling the, if you've seen any of my other videos, you see me assembling the scene and then run it. The overwhelming majority of what's going to be in the scene doesn't start off in the scene. It has to be instantiated when the scene begins. Now there will be a few things. Let's put the ground in, so we'll drag and drop the board. and like we normally do, at least in some of the other videos, we'll expand its size, we'll scale it, and we will rotate it. That will be our ground, and this will also receive Physics 2D Box Collider, but not a rigid body. So we want it to be able to detect collisions, but we do not want gravity to affect it. We don't want anything, we don't want this moving. It needs to be immovable. Now, the one thing that we're not going to instantiate, at least not the moment, will be the player. So just like a little missile launcher. For this, we will also use Physics 2D, Polygon Collider. We do need to also give it a rigid body 2D because we are going to be moving it left and right. So we need to add velocity. To add velocity, you need a rigid body. Let's give it... I'm going to leave the gravity scale as 1. We'll also give it a little bit of a linear drag. Again, game balance reasons, we may change that. Here's what's going on. If you apply velocity, okay, just like in real life, there's friction against these two surfaces because gravity is pulling it down against this surface. So if you, if we put in code that says, okay, here's the velocity, even though you give it velocity, the gravity scale will bring it down to 0. It will slow down. The linear drag will also help with that too. So if you don't have gravity scale and you don't have linear drag, if you hit the button, it'll just keep going. The velocity only needs to be applied once, and object in motion stays in motion. So those are the kind of things you have to keep in mind when you're working with this kind of low-level physics that you have in a 2D game. Alright, so now let's actually start putting in some code. Now, like I said, we may eventually turn this into a prefab because, generally speaking, if you're playing some kind of Space Invader game, your ship gets destroyed and a new one spawns at a certain spot, so it's easy enough to turn it into a prefab if we really want to. So the first thing we're going to do is let's give some player control. So create C#, and we'll call this base control. So we're going to click on the base, going to drag and drop the script, and now we're going to go ahead and open that up. Okay, so the first thing that we're going to do in this script is we're going to add in the variables. So I'm going to paste these in and then we'll review them. So the first 3 are key codes. In other words, these variables are going to be used to check if certain keys are being pressed. And they're pretty self-explanatory. This one's going to be for move left, move right, fire the missile. Now this one, public int total CUR equals 0. This one's going to keep track of how many missiles are currently in the air. Okay? We don't want to be able to fire an unlimited amount of missiles. Usually that's the main form of control in a game like this, is you can only have 1 or 2 shots in the air at a time. By using a variable, you can just tweak it. Like maybe there's an easy mode where you can have 3 missiles in the air at a time, a medium mode where you can only have 2 in the time, and a hard mode where you can only have 1 at a time. So it definitely lets for flexibility as far as difficulty. And then public transform missile object. What this is going to be is, since we want to fire the missile, we need to be able to instantiate it. So to instantiate it, we need to refer to it, and you do that with a variable. So let's go ahead and save that. That is attached to base. And so you're going to see that they appear here. So we're going to use the typical WASD control. So A will be left, R to move right will be D, to fire the missile will be space, and the missile object is this prefab. Now, while we're looking at this, a couple things occurred to me. For the missile, probably going to want to scale it down a little bit. It's probably a little bit too big, so probably don't want scale of 1:1. You can do like 0.8, 0.8. Not absolutely vital, but if it's too big, then it's aiming doesn't become much of a challenge. And the second thing is the missile needs to be a trigger, so let's go ahead and put a check there. Because if it's not a trigger, then what's going to happen is it's going to collide with this as soon as it gets shot out of it. Okay, so now in the update section we just need to start checking for those key presses. And that's going to be the bulk of the player side of things. The enemy side of things will be a separate script that's going to be attached either to a game master object or attached. There's probably going to be some functionality attached to the prefab for the enemy itself. So if input dot, there's a bunch of different get keys. Like there's get key, which is basically a rapid fire detector. That as long as the key is being pressed, then this is seen as true, and it will perform the statements dependent upon the if statement. If you do get key down, it only happens for one frame, the frame that the key is pressed down. Likewise for get key up, it will only perform once, and that's when the key is released. Different reasons why you would do that, like get key up, maybe you're charging a weapon and you don't fire it till you let go, so you would do get key up. So since this is for movement, we're going to do get key down. So as long as the key is held, then just get key, not get key down. We're going to do get key. That way, as long as the key is held, then it will continue to be true, and it will do what was about to follow this. So move L. So if move L is being pressed, then get component. What component? Well, we want to alter the rigid body 2D. What attribute? Velocity. And we want to set up a new vector 2, and that vector 2 is going to be positive. Let's see, if we're moving left, then it's actually -3, 0, and that's it because it's a vector 2, only 2 variables. So -3, negative is moving to the left. So now what we want to do though, I want to surround this with brackets. Best practice, if it's only one line after an if statement, you don't need the brackets, but if you go ahead and add like a second or a third line and you forget to add the brackets, your code won't work. So really best practice is just to put the brackets in right away. Now what we have to do is do two things. We're checking for move R rather than move L, and it will be given a positive velocity rather than negative velocity. And we'll paste this one more time, although the bulk of it we're not going to reuse. So for this, it's going to be the fire missile button, and this is where we use get key down. We don't want this to rapid fire. So since these are looking to move the character, move the player, you don't want to have to tap, 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 tap. Be very repetitive. So this you do want a rapid fire situation for movement. This you do not want rapid fire. This you want to do a one-off. So what happens? Instantiate missile object. Now, I wish I could just put in transform.position. What transform.position does is it says, okay, whatever the position is of the object that this is attached to, use that position. So this script is attached to the base, so it would grab the position of the base. The problem is, when you look at the position, it's looking at the pivot point, the hot spot, and it's right there. We really don't want the missile to appear there. We kind of want it to appear higher up. So what we're going to do is we're going to make it a little bit more complicated. We're going to do new vector 2, and then it is transform dot x, because there's nothing wrong with the x position. The problem is the y position. So transform dot y, and we want it to be a little bit higher up, so we'll say +1. That's probably a little bit too much. So this whole thing is just the second argument. It's the position, because there's 3 arguments. There's what's being instantiated, where it's being instantiated, and then the rotation of it. In that case, we want to use the missile object's rotation. Save that. And that pretty much should do it. Oops, error. Oh, I missed a... There's a semicolon somewhere. 39, comma 108. Yep, actually I missed a parenthesis. Okay, so it's actually transform dot position. Sorry about that. So, as I originally said, that if you're just using the if you're just using the location, this entire thing could be replaced by transform dot position. But because we're breaking it up, we need to use transform dot position dot x, transform position dot y, because we're modifying it. Sorry about that. This little carelessness on my side. Okay, so let's move left. I'm going to hit A, and it slows down. Move right, slows down, and now let's fire. Very nice. Now that's the rapid fire that we're not going to want. So to take care of that, we now are going to, when we fire the missile, we want that total current. So total current plus equals 1. In other words, whatever this is equal to, add 1 to it. So that's step 1. Step 2, we modify this with a second check. And that is if total current is less than 2. So moving left, moving right. And then we fire. Fire again. See how the missiles are still over here? So even though they go off the screen, it's not like they auto detonate. So we fired 2 missiles, and now they, I can't fire anymore. So that's working perfect. So what's going to happen is when the missile either goes off the screen or the missile strikes an enemy, it will auto destruct. So let's go ahead and put in that auto destruct, and that should wrap it up for this video. So we're going to right click, going to choose create, C# script, and we'll call this missile control, if I could spell. Now, as I mentioned before, that just because it's a prefab doesn't mean it's etched in stone. You can just drag and drop and add new components. So let's go into that missile control, and for now we're just going to check for its position. So if it's too high up, then what's going to happen is it's going to self-destruct. So let's just quickly move this up so I see. So what I'm going to do is I'm just going to look at the position. So it's 5.5, so we'll bump it up to 6. So if transform dot position dot y is greater than, we said 6, then destroy game object. So we have a problem. When the game object gets destroyed, we need this variable to be reduced. It's not a static variable, so this script, this object won't be aware of it. So what we have to do is we have to make one change. This will now be static. We should not have to make any other change, because if you're referring to that variable within the script that it's declared, you don't have to put in the name of the script. So right here, okay, we don't have to put in base control dot total current, because this is base control. It is that script. But any other script on any other object, yes, we have to refer to this. So that's what we're going to do. So base control dot total current minus equals 1. So now what that's doing is it's saying whatever this is equal to minus 1 from it. I think that's all it should take. So we'll fire off 2 really quick. And there we go. If you notice, they disappear over here now. So we'll fire off 2 really quick, and then they disappear when they go off the screen. Excellent. And I'll also just do one more movement restriction. So game object, create empty. We'll call this left bumper, and it will have physics 2D box collider, but it will not have a it'll have a box collider, but it will not have a rigid body, because we don't need to apply any motion to it. And this will be right bumper. So by the name, as you can tell, what we're going to do is we're simply keeping the character, the player, from going too far left or right. There we go, so it stops. And since there's no rigid body on it, we don't have to worry about it moving. So it can detect a collision, but there's no movement. That looks like that probably moves a little bit too slow, but that'll just be a game balance issue. Okay, so that should do it for this first video, and the next video will deal with the actual enemy formation.